Hello Geometry. This lesson is entitled Triangle Angle Sum Theorem. Now the triangle angle sum theorem is something that most of us, if not all of us, already know, is that the three interior angles inside the triangle add up to 180 degrees. So angle A plus angle B plus angle C is 180. So we're going to use that now, and we'll do the proof in class, but we're going to use that now to find other angles within other triangles. Okay, so here it says find the values of x, y, and z. So first, if you look at x, there are technically three triangles in this diagram, but we're going to focus on this one for x. Okay, well, we know two of the three angles. If you know two of the three angles of a triangle, you would just add them up. So we have 65 plus 39, which gives us 104. And we know the third one has to add up with that to get 180. So then, therefore, we subtract that value from 180. So we end up with, at 6, that becomes 7, we get 76 degrees. So x is 76. So that's one of our answers. Now we still need to find y and z. Well, if you look at this yellow triangle, we know that the top one is 21 degrees and the bottom is y and z. Now we need two angles in a triangle to find the third. So if we only look at the yellow triangle, we cannot solve for y or z. But what we can do is remember what a linear pair is. So in this case, notice that x and y are a linear pair. They're supplementary. Well, we already found 76 is x, so therefore we subtract that value. Okay, that's a 0. 76, we end up with 104. And that is what y is. So y is equal to 104. Lastly, again, let's go back to the yellow triangle now. Now that we know what y is, we have our triangle here on the right. We know the top one's 21. Now we know y is 104, so we're going to add those values together. We end up with 125. That means z is going to be 180 minus 125. So therefore, we get 55 degrees. So z in this case is equal to 55. Okay. Now if you want to check your work, notice I said there were three triangles in this diagram. Well, if you were to outline the entire one, the entire triangle, that's the big triangle, these three angles, angle F, angle FGH, and angle H, have to add up to 180. Well, the bottom one is 65. This one, when you add the 39 and the 21, gives you 60. So again, if you have 65, let me put that in a brighter color. You have 65 plus the other 60. That leaves you with 125, which means z would have to be 55, which it is. 180 minus 125 is 55. So that's just a way you can check your work as well. Okay, so we might have to use one triangle's degree measure in order to help us find the degree measures in another triangle. Okay. Now, new concept here. What happens if a side of a triangle is extended? When a side of a triangle is extended, what gets created is an exterior angle. So angle 1 right here, notice is on the outside. It's an exterior angle. Now from the 1, angle 3 and angle 2 are considered remote interior angles, because remote meaning away from, it's not connected to angle 1, which is an exterior angle, and they're on the inside. So remote interior angles. Now, if the measurement of angle 2 is equal to 40, okay, if angle 2 is equal to 40, and angle 3 is 60, what is the measurement of angle 1? Well, notice here we have a triangle, so 60 and 40 add up to 100, which means this would have to be 80 degrees inside the triangle. Well, again, we have a linear pair here. They're supplementary, so angle 1 and the 80 add up to 180. So if you subtract those, you end up with 100. Okay, so angle 1 is 100 degrees. Well, that's what we said angle 2 and 3 are when you add them together. So now we can come up with a little formula here. What can be concluded? It's called the triangle exterior angle theorem. If you know one exterior angle, it is equal to the sum of the two remote interior angles. Okay, so here's our theorem. An exterior angle is equal to the sum of the two remote interior angles. So now we're going to apply that. Find the values of the missing angles. So again, this angle 1 is exterior. 40 and 30 are the remote interior. So all you have to do is add those together. So the measurement of angle 1 is 70 degrees. Now what if you know an exterior angle in one of the remote? How do you find the other remote? Well, instead of saying, technically you can set it up in the same manner. One interior angle plus the other, let's use proper notation, plus the other angle is equal to the exterior angle. Okay? So therefore you would subtract 70 from both sides. You end up with 43 degrees. Okay? So again, if you know an exterior angle in one of the remote ones, you could just subtract that value to find the other remote interior angle. Alright? Alright, we're almost done. It's a very short video. Here it says you can classify an angle by its measure. Also, though, you can classify a triangle by its angles and its sides. So let's start with angles. If all three angles, and again, these markings, okay, when we have these markings on diagrams, that means they are congruent. So in this case, all three angles are congruent. So if we had to classify this this triangle solely by the measurements of their angles, we would call it equiangular. Okay, notice all the angles are congruent. Okay, again, but you have to go off markings. You can never go with looks like. It looks like they're congruent or whatnot. The markings have to be there in order for us to say for sure. Now this next one, there are no markings, so we cannot assume that any of these are congruent to each other. But we do know that this one right here is acute, less than 90. This one is also less than 90. And this one is also less than 90. So if all three angles are less than 90 degrees, we call it an acute triangle. Okay, so this triangle is an acute triangle. Again, all three angles have to be less than 90 for it to be an acute triangle. Our third one here, notice angle A. Oops, sorry about that. Angle A is acute. I moved the background, sorry. Angle A is acute. Having some troubles. Angle B is acute, but notice right here, that symbol is 90 degrees. So if a triangle has a right angle symbol in it, well, logically, it would be considered a right triangle. Actually, let me go ahead and add triangle to these first two as well. Okay, and lastly, again, there's no marking, so we don't know for sure what the degree measures are or if one is congruent to the other. So we have to go by what for sure we know. Now, we for sure know that this angle is acute. We know that this angle is acute, but notice this one right here is an obtuse angle. Okay, it's greater than 90 degrees. So if there's an obtuse angle in a triangle, we would call it an obtuse triangle. Okay, so again, we have equiangular, all the angles are congruent. An acute triangle, all the angles are acute. A right triangle, where one of the angles is a right angle. And lastly, an obtuse triangle, where one of the angles is greater than 90 degrees. That's how we label it, again, by its angles. Now let's talk about classifying a triangle by its sides. So here, notice the markings are on the sides. For this first one, we have all three sides are marked with the same amount of marks. They each have one mark. Okay, here goes one mark, one mark, one mark. That implies that all the sides are congruent. If that's the case, this triangle will be considered an equilateral triangle. Notice the one with the angles was equiangular. This one is equilateral. triangle because all the sides, the lateral sides, are congruent. Now the next one, notice we only know that 2 of the 3 sides are congruent. If at least 2 of the 3 sides of a triangle are congruent, then it's considered an isosceles triangle. Okay, again, 2 or more of the 3 sides have to be congruent to be considered an isosceles triangle. Now it does imply, if it's an isosceles triangle, that these called base angles are also going to be congruent to each other as well. Okay, and for our very last one, notice there's no markings, so we can assume that no sides are congruent to each other. If no sides are congruent to each other, it's considered a scalene triangle. Okay, again, no sides are congruent is considered scalene. So, recap: 3 sides congruent, equilateral; 2 or more, isosceles; no sides, congruent, scalene. Okay, that's what we're doing today for triangles. Okay, again, the triangle sum theorem, the interior angles will equal 180 degrees. That is the main thing about this lesson today. Okay, good luck.